Okay, do you hear me?
Yes, we can hear you, Ivan.
Excellent. Do you see my slides?
Yeah. Here.
All right, very good. So this is all about registering our data resources. And I will present a standard metadata and ontology that were developed for PITHIA. So the first draft has been released, and I will explain what makes it still draft, what needs to be finished in order to be ready to start registration from all our participants. So here's the plan for the next, let me see if I can progress my slides. Okay. Okay, I can. So here's the plan for this presentation. So I will first review again and again the ISO standard and what was done for ESPAS very quickly. So as Thomas already said, the PITHIA is just a simpler version of ESPAS. And then we'll go to the main part of this presentation, so we discuss what metadata needs to be prepared by every participant in detail. And I will use some example registration documents that are now available already. So there were 3 different resources that I prepared registration files for: DIDBase, IRTM3D, and Raytrix CQP. These are the 3 resources that almost done. I'll explain what needs to be finished in order for everyone opening these files and looking how to modify. We just can copy and change the relevant parts of these documents, one possibility. We will discuss maybe an online registration form will be a better solution. Certainly it can be. Okay, let's start with the beginning. This is the observation and measurements ISO standard, 100 pages squeezed into a single sentence. Let's look at that again. Observed property describes the phenomenon for which the observation result provides an estimate of its value using an observation process. Okay, let's look at that with the details. So let's look at phenomenon on the right. Where's my pointer? Oh, there it is. Okay, so phenomenon is a mother nature. That's what we can observe. So observed property is the property of this phenomenon that we can sense, observe with our instruments, or model with our models. Okay, so the result is the output of our observation on the model. So that's essentially, in our case, it will be URL to the data, to the model that the eScience Center will be able to provide access to the data itself. So value here, it means it's numerical value is what we will be able to get as a result of observation. And one last piece of this explanation is the process. The reason why the process is here is because our means to observe Mother Nature are still limited. We may get only particular fragment of the whole Mother Nature phenomena. We can get description of ionosphere in one location, for example, or we can get only a horizontal projection of the plasma velocity, something like that. So the process describes exactly what observed property was, how it was done, how was the observation done, in what steps. So these are the keywords that all of us will have to use when we are preparing our registration. Here's the simplification that was done using the original ESPAS design for. On the left, we have our ESPAS design. Some of our colleagues will recognize it. So we have a collection of observation items, 1, 2, 3, 4, 5, etc., etc. Each of the observation, just like in the previous slide, has a result, particular result. And if you look inside results, then you will see that certain process capabilities were used to produce some of the observed properties. So you see there's a multiplicity everywhere here. This observation has a particular time when it was made, and it refers to a particular area, observed extent somewhere. And then you have to multiply all that by 1 million of your data events. So when you're collecting observed data. So that was quite a bit of work to register, say, every ionogram. We have about 50 million ionograms in our collections. That would be 50 million observation files with the result, with the use process capability, with observed property specification. Quite a bit of work. So for PITHIA, we simplified all that. So we have observation collection. Instead, as you see, we do not have time of every single observation anymore. And what we have a collection results. So everything which our collection can possibly report as a result, everything will be piled in a single description. That's the difference. So one collection and results description, much easier. Now the process capability can be multiple because again, depending on what our collections are, some of them may be simpler. There will be just one process that records, say, magnetic field, right, with 3 components. Or maybe it's going to be a little bit more complicated with multiple observed properties that can be extracted from our single observation. Or maybe a model that can provide multiple things as it computes. So that is our approach here, simpler. And let's get into details. How do we do it? So observation collection is our items. So everyone will be preparing this description of a collection that they provide to PITHIA. Observation collection is essentially what used to be observation now becomes observation collection. So it still complies with the ISO standard components. If you look inside that observation collection, what you will see there will be a result. OM stands for observation and measurements, so standard result. So there will be some collection results inside. What are these? These are just URLs to the data provider landing pages. Where are these located? There are 3 options that Thomas explained previously. So that will be the outcome of our search. We will get the links to the data in that section. The next item is procedure. So procedure is something linked to a description of process with all the capabilities in there, and each capability will point to one observed property. Now, the thing which was missing from previous slide is a parameter, which will be just a list of all input processing parameters of the collection. So, for example, if the model requires a sunspot number or a KP index in order to operate, that's where you need to list all the parameters for the model that are required in order for it to run. And the last items in the observation collection is something called feature of interest. Essentially, it's where the phenomenon is observed. So in Thomas' explanation before, the inner heliosphere is actually a feature of interest. That's so it's a vocabulary controlled expression of real world objects. such as, for example, ionosphere or the heliosphere. So 1, 2, 3, 4. 4 items are the key things. So we are ready to look at our diagram. So these are documents. The blue ones are prepared by each provider. The green ones are available already. These are terms from the ontology vocabularies. So on the left, observation, collection, and XX stands there for specifics. For example, DidBase or Swift or things like that. So that's going to be a particular name. So what we will create is a file which will explain what the observation collections is. So inside of it, you will have to give it a name, provide a description that will be displayed to the user. And some of the things that are here provide additional details for the collection itself. So the project is a link to a file which says a project XX. What the project is just the whatever research activity has a particular name. Say it can be DIAS, for example, or the project can be RION, or whatever name for the umbrella project activities at your organization, that will be described in this document. So as you might imagine, it's just one document explaining where is the link to that project and, and who are the people that you would like to contact in case you have some information. Then here you describe again these people who are specifically responsible for that collection. And then 1, 2, 3, 4 are the items from the previous slide. So you have parameters, you have result, and you have procedure that goes into a process below. That will be explained a little bit later. And you say what the feature of interest is. And these are the terms from a particular different. So in order to describe the related party, as they call it, we need to have an organization. That can be NOAA, for example, and the list of individuals at this organization that are responsible for the various aspects of this collection. So let me try to demonstrate. Yeah.
Ivan, can I ask you something in the previous slide? Under the data format, you propose there to have some predefined options for the data format, or we can define whatever format we prefer for our data.
Right, it's just a description. So if your data collection is just images, then the data format will state that this is a, say, JPEG or PNG. There's a list of data formats already available. And if you have a particular format in mind which is not in the list, we'll just expand that list.
Okay, and I assume that for the license is the same.
Right, for the license, the same. There are standard licenses sometimes, but sometimes they are particular to the organization. And the terms of these licenses will be stored as a dictionary.
Okay, okay. Okay.
These are actually copy from this past. We have data. We have data format description in this past, and licenses were also listed in the ontology section. Any other questions so far? Let me just go to a file. Maybe it's going to be easier. So let me see. Do you see my new screen now? Black background.
Yes, we do.
Okay, very good. So this is the tool that we will eventually recommend to everyone for those of us who are preparing the descriptions. The tool is called, I installed it myself. I haven't used it before. So the tool is called Visual Studio, VS Codium. You just download it from the web. And when you go to a file menu and open one of those files that you're preparing, that's what you will see. So this is a file called collection dbase. Okay, so this is the header.
Actually, this tool that you download from the web is an XML editor. Right?
Correct. Yes.
Okay, and what is the name again?
It's VS Codium. Let me see if I have it here. About that VS Codium.
Okay.
That was a recommendation from Thomas' team.
Yeah.
And I downloaded just to see. I have my own XML editor, but I thought I would use this one so that everyone is familiar with the environment where these files will be prepared. It's very easy, just download. There's an XML extension. As you see all these things, you can follow the link. There are some validation capabilities. It's all nice. I have to learn it myself. I'm not yet that familiar with it, but I will be. It's useful.
Ivan, can I make a very quick comment on this? So obviously, if somebody knows or uses a different XML editor, that's also completely fine. So we do not have to use all the same because this is outside the Science Center. What is important at the end is to create a well-formed XML. So if somebody uses something different because they are more familiar or got used to that, I think that's perfectly fine.
Okay. So you see there are a few headers which are standard. You just suppose you need to register different collections, so you come overtake this file and instead of DIDbase, you put something else. So collection DIDbase is the local ID. It's the section in the identifier. So the same name is here, collection DIDbase XML. So these are things when you created it, when you last modified it, what's the name of it. And there's a description, which is just plain text and says that this DIDbase collection contains that, and this. And then there is a project link. So the project will have to point to a different file called project Rion. So you have to prepare that file, project Rion, explain what that project is, realistic ionosphere. Then you say that, yes, there's this individual Galkin here, individual at LGDC, there is someone called Galkin, and who's what the organization is organization LGDC. So that's the responsible party part. Now here's the result. So you just specify all the URLs. Here's the URL. That's the one, HTTPS Giro UML edu. I think I used the font is too large for that. Let me see if I can scroll it right so that you see what the links are. All the other things you see, there's all the service function is web portal. So a link goes to that Giro UML edu DIDbase. And then that's it, description. So that portal is the display of ionogram images. So why there's all this particular language of something X millions and things, that's what makes it standard. So this is ISO standard. You just keep it and you change the important part of it. That's where the collection is located on the internet. Here's another resource, online resource, that's going to be a SSAU Explorer. Excuse me, SSAU Explorer software. And then, and the final, there's another one called a fast car. Fast car is this page of the servlet that to retrieve numerical anagram derived data in plain tabulation. So basically, that's the result. So your collection reports where to find the data. And I'm sure that eventually some of these links will be pointing to pages at the eScience Center where you can click the button. So that gonna be provided by the science team. So that's the result. And the last remaining items, the procedure for this particular collection is explained in the file called process database. That's probably the most difficult part of this registration, is to write this file, process database. And then observed property is not used here because it's all inside the process. And the feature of interest, so collection database, that's the standard language from the ontology. So that's a E region, F region bottom side of ionosphere and E region of ionosphere. That's where the data that are registered, that's where it is observed. And the final item is the license to the data and LGDC space data policies. There's a document explaining what are the conditions and requirements if you have anything specific, like in our case, or something standard, standard license that is accepted for your data collection. That's it. So that was the collection file. Not too bad, actually, relatively light. Okay, so VS Codium application is our recommendation, and certainly you can use something else. Okay, so where do these files go? So there will be a PITHIA metadata server eventually. It will be hidden from the data providers because it's somewhere inside, but now it's our workshop. We need to discuss it a little bit with all of you. So where are these files going to be piled? So it's a single server platform somewhere, which has these files of 3 different categories. So there will be a folder called resources. That's our suggestion. So all the registration files go into that folder. There's also a folder called ontology, where the ontology vocabularies are, okay? And there will be a folder schemas, where the XML schemas for the file validation. So all of these 3 things are actually in a good shape right now. Resources have draft versions of the registrations for the 3 example collections. And so the question is, where do we place that? How do we call this server? The suggestion was to use something with the PITHIA. Oops, sorry. Okay, here's my pointer. I cannot highlight it like this. Okay, so the PITHIA.eu is something that we would like to keep. It's going to be permanent. Yeah, all the collections will be pointing to that place. Why VO? I really don't know. It's not. I picked something in the email discussion that the VO PITHIA is available now. What others doing when they place these particular registration files. Here's an example for the observation and measurement standard itself. So something called www.opengis.net. Here's another one. So it's a www.3org, some year, xlink. So we could do www.PITHIA-EU, and then all our ontology and things like that will be stored in this convention. So
maybe Levente has a comment here. I see that he had his hand right.
Hello. Yes, just a short comment on that. We just started the process of registering the PITHIA-EU domain name. Once that goes through, any subdomain in front of the PITHIA-EU is available. We can organize it as we wish. So either just www.PITHIA-EU / and then we create separate folders for the resources, ontology, and schemas, or you can use dedicated domain names like schema PITHIA-EU / whatever, and then those can be pointed to different places or the same server. We can organize it as we any way we want. Just keep in mind that the name of the VO, which is in this canonical format, which is very similar to a domain name, that VO PITHIA-EU, that is just a name. It is not in any shape or form linked to the PITHIA-EU domain name in the DNS, global DNS system. The latter one, we just started the registration of it. I will confirm on the mailing list when we actually own it.
Very nice, very, very nice. That type of freedom will be useful to us. I do have my suggestions, but again, this is usually up to the team that maintains these resources, so they have a better understanding what they prefer. So it could be as easy as saying we would like to do this or that. So that's we don't solve it right now, but let's see what our preferences are. So for now, everything inside uses that VO. But we can change it to www, for example.
Yeah, the sooner the better, because once you agree on a standard on how you want to organize stuff, then you can start using the actual URLs in these XML files. Otherwise, later when we actually got an implementation going, you will just have to update all the XML files. So I suggest to agree on something. My suggestion is in the chat on Zoom. And after everybody agrees on a specific standard, then you can just use that in all these XML files and you won't have to update them in the future, because the implementation will be done so that it matches these URLs.
Absolutely. So maybe www is not a good name because it sounds like a web page. Metadata, MD, so we'll discuss it. One last point on this slide. You see HTTPS, S stands for secure. That's my suggestion, because the older standards are still using HTTP because there's a pressure of millions of existing registration done already. But from our personal experience, HTTP is no longer considered to be secure enough for in the modern times. So NASA went through a painful exercise of converting all of their resources from HTTP to HTTPS. And that was really not easy process. So I suggest we just use HTTPS right away.
Absolutely.
Okay, let's have a look at what's inside. My standard Windows file manager had a very small font, so it's not easy to see for you. So this is now you're looking at the particular folder. That would be that particular server that with the name that we will all agree. So inside you will see 3 subfolders. So schemas are the PITHIA schemas. These are the files that are ready. You don't need to work with them anymore. Resources, that's where ontology is where the ontology goes, all these RDF files. And everything that our data providers do, they do it inside the resources folder. If you look inside, these are different files, go to different folders. Here's the collection folder inside. I think we should keep it in the namespace PITHIA. So these are collections that belong to PITHIA. We could do differently. We could use the name of the organization as a namespace, but that is one possibility. PITHIA, so look inside. These are the 3 collections that I was talking about. And if you look at this file, that's what we just saw on the VS Codium page. That's the file, that's a different file, that's a different file. So the files will be piling here as a collection. And the rest of the documents, so you see there's different other documents already available. Individual, say, here's our fearless leader, Anna, registered as a, you see there's information about her telephone and things like that, telephone number. I provided one for myself, so there's things for the individual. So, but let's be systematic and go into the rest of the description. So inside the process is most difficult part of the registration. So process. So process itself, say process did base. Process did base, inside there will be a description again, and there will be some number of acquisition components and some number of computation components. So acquisition is everything which is measured by instruments. Computation is everything which is computed by computers. I apologize, it seems like my keyboard is very sensitive here. Okay, so the process will have this a number of components specified. In case of a model, there will be no acquisition component because there's no measurement involved. It's all computation. So in current design, that's how we will tell the difference between model registration or the data set registration. So if you go to acquisition components, that's going to be a separate file called acquisition, say DBase, and there will be description of things in terms of capability, what things that we can do. And each capability will have the observed property that understood, so we can observe critical frequency of the F2 layer. And then there are several items that describe how this observation is done. I don't think we have enough time today to explain it in detail. This is a copy from SPAS project. Dimensionality, for example, is it just something that you measure at one point in space? Or is it a 3D volume? Is it an image? Is it a spectrogram? Is it a time? Not the times, is it a vector, for example, right, of velocity? So that type of language, which is standard, everything green is standard, you will have to describe that observation at one instant of time. And then another description is the in time progression, what your measurement will become, or model computation. No, this is acquisition. What timeline, what it will become. So if it's just a single point, then it will become a time series display. If this is a frequency spectrum, that will become a spectrogram in time. So things like that. Then the next item is vector representation. If the phenomenon that you're describing has a vector nature, say you're describing a plasma velocity, which is a three-dimensional vector, but your capability is only to sense a particular projection. Say, I can only do a line of sight, or I can do only horizontal component of something. So that's going to be described here as a vector representation. CRS is the system of coordinates. Sometimes it is important to know that your acquisition is working in particular system of coordinates and in which units. That every single item that you are measuring acquisition-wise will have to become in one capability description. And then the all capabilities listed, tool remaining items are instrument itself. So you go, excuse me. You go and you prepare the description of your instrument. It's relatively simple. You just describe plain text, what your instrument does, and the type of instrument. There's a particular categories, so that becomes searchable if you're looking for rheometer, for example, or GPS receiver or something like that. So it's a particular category that you can narrow down all your searches to a particular instrument type. That's the way it's going to be done, by a type of instrument. And then again, for some reason in our SPAS design, we also attach for every instrument, you will have which organization operates it and who is the technical director of the station, for example. So that's going to be instrument type. Platform usually means observatory. Where is it? Is it on the spacecraft? So it's going to be a moving platform. Or is it on the ground? So that's going to be a ground-based observatory, or like a earthbound observatory. Yeah. So again, the same thing. You have the name, URL to that particular observatory. Yeah, I'm not sure if we need it. One means it has to be provided. We can discuss it. Do we need to, for every observatory, do we need a URL to it or not? We can decide. Maybe that should be a 0 or 1. Then some description again. These are all plain text. And the platform type basically means, is it moving or static? So that's the standard term. And then a related type, role and party. Again, people who are responsible for that observatory. So that's the acquisition part. For example, if you take a picture of the sun, so the acquisition will describe the picture, image. So you will say that you were measuring the intensity, things like that. In case of the ionozones, that's going to be ionogram measurement. So your observed property will be a field strength, electric field strength. If your antenna are electric, then you will be recording the electric field strength. So that's the part relative to acquisition. Oh, sorry. So the computation component is what you do with the acquisition, with acquired data. For example, the ionogram itself cannot be assimilated in the models. So same with the photo of the sun. You need to extract some useful information from it, which is considered to be a computation. You have to describe what you do in order to count sunspot numbers or scale ionogram to find traces of reflection and describe their properties. So things like that will have to be described in the document called Computation Exhibits. That can be also a model. So in that case, you need to describe, which is a free text. You describe what your model does in order to produce its result. And what exactly it produces, again, there's a little capability, which is most difficult part. You have to describe every single output of the computation. Is it the critical frequency? Is it the scale height of the ionosphere? Is it the shape and classification of filaments on the sun? So all of that explanation will have to be provided by the participant of this project. Now, I think we are already only 30 minutes left, and this is actually one of my last slides. I only have to one more slide saying what things are remaining to do. And if we would like to give Thomas another 30 minutes, and then he's gone for his next meeting, then let us quickly go through the things that are required to finish. So there's a comment from the team that the server is practically, we just need to decide how to call it, and it's going to be ready. Now, that's item 1. We already discussed it. Nice. Item number 2, what happened that I was able to find only SCOS definitions of ontology that need to be converted to RDF. But question mark here means that it probably, I think, we already have these RDF files. Is that correct? For the SCOS definitions. If not, we need to keep pushing the idea that these SCOS definitions have to be massaged and converted to something that you can reference in our XML files. We cannot reference SCOS definitions themselves. We need that RDF files.
So Ivan, I cannot answer this. David can answer it if he's in the call. I'm not sure whether he's in the call.
Yeah.
We are going to sort this out.
Okay. So once those 2 items are done, 1 and 2, I can run the validation using our tools. So this example registration files will be finalized and everyone will start the process of preparation. But before we do that, we probably need to set up some version control system for registration so that I can use it. So if other contributors are working on the same documents that I'm preparing in terms of links and items and things like that, so that we do not override each other's work. So the easiest would be to run it through a version control system. And when this is done, so we can start explaining the partners how to do the data registration. And we will provide technical oversight on all this preparation of the documents. Well, given the constraint of files, given the constraint of time, do we really need to go through all these other things? Say process did base, let's look inside. So you see there are several computation, one acquisition component.
Maybe we can leave these details for the afternoon.
For the afternoon, let's do that.
What do you think? Huh? Yeah, okay. Because we will have also some interaction with the teams on discussing how specifically they will register their data in the system. Okay. So maybe it is the best place to go into details.
Okay. In the afternoon then.
Okay, yes, if you are available, Ivan, in the afternoon.
I am.
Okay, thank you.
No, I will support it, yes, certainly. It's important.
Great. And we can also specify a bit more of these remaining items in respect to a time schedule. But of course, we need the Westminster team to follow this discussion, to understand when all these tools will be validated and ready to be used by the groups.
Okay. Well, in the interest of time, let's then proceed to Thomas' presentation, I think, and additional details of registration we'll review in the afternoon.
Great. Thank you, Ivan.